in this lecture now, we're going to put the power of being able to identify from our periodic table the type of ion that forms with main group, now how we put together a neutral ionic compound, ionic we'll explain later, all right, or name a neutral ionic compound. How do you recognize it? Well, it'll be a metal and a non-metal from the main group, from the S&P, all right? So we'll start with an example that you are very well aware of, and then just use it as a template. Okay, you all know how to name that. That is called sodium chloride. And that's all there is to it. The metal is named first, all right? So this is never called chlorine sodium, all right? It's the metal is named first, and it is just the exact name that you get off the periodic table. So you just give right its name, nothing else, that's it. For the non-metal, you change the ending to "ide." So in other words, Cl is actually chlorine, isn't it? All right, so I changed the chlorine to chloride. That "ide" designates that it's an ion, all right? Okay, now, just a couple where the ending gets a little weird. Sulfur, obviously, goes to sulfide. Guess I should put, who knows, I never know how to spell that. And then phosphorus. Simply goes to phosphide. Because somebody decided that phosphoride sounds kind of silly. So those are the two that can be a little bit different from what you might have expected. But with that in mind, let's look at page 5 of our notes and try a couple of these. All right, so using the template of sodium chloride, I'm just going to name the metal right from the periodic table. That is magnesium. And this is still chloride. Doesn't matter there's a 2 there, absolutely not. Okay, with ionic compounds, just saying the name gives us all the information that we need. All right. To show that point, let's drop down a few and look at this one. All right. Once again, very easy. What is the name of this metal? Why, it's calcium. And what is the name of that non-metal? Well, I changed the ending to phosphide. All right. Those numbers are irrelevant in naming. It's just what is the metal, change the ending of the non-metal to "ide," and you're good. All right, so you can try the others on your own. Now, writing the formula, you have to remember that it's neutral. So the positive from the metal and the negative from the non-metal must match. All right, and I've made, first of all, kind of a training wheels, this little chart. So you've got a sodium, a barium, and an aluminum. Those are your metal ions that lose electrons. And then you got an iodide, an oxide, and a nitride. All right? And so the idea is I need to put these together so that they're neutral. Well, a +1 and a -1 go together 1 to 1, don't they? Because that's just fine. All right? However, when I have a +1 and a -2, then I have to get this neutral, and how I do that is I need 2 sodiums for every 1 oxygen to balance it out. So I would write that as a subscript, 2 sodiums for every 1 oxide. All right, and then using that same logic, if I've got an N3- and an Na+, then to balance the charge, I'm going to need 3 sodiums to balance that 1 nitride. And how do I write that in a formula? I need 3 sodiums to balance 1 nitride. Okay? All right. So So let's look at it with a +2 ion. All right, well this time, now I've got more positive than negative, don't I? So now I need 2 iodides to balance that 1 barium. And how would I write that as a formula? Barium iodide. Okay. A +2 and a -2 balance each other. So I just put 1 barium and 1 oxide, and it's balanced, okay? Balanced meaning neutral from charges, pluses and minuses. Okay, and this combo is always the favorite because you got to do a little math, all right? You got a barium 2+, and you got a nitride 3-. All right, I've got to balance the charge. So saying what is the least common multiple of 6, well that means I would need 3 bariums for 2 nitrides, wouldn't I? Okay, sometimes if the charge is not the same, you can just crisscross the charge, all right? That's a little trick, all right? That doesn't work if the charges are the same, don't try that. But if the charges are different, you can usually crisscross the charge. So the formula is I need 3 bariums for every 2 nitride to be neutral. So that is the formula for barium nitride, okay? And then I think you get the idea. If I got a +3 and a -1, I need 3 of the iodides. I got a +3 and a -2, well then I need 2 aluminums for every 3 oxygens. And then finally, if I got a +3 and a -3, well they just go together because they balance each other, 1 to 1. I need 1 aluminum for 1 nitride. Okay. But that was the training wheels. That was me giving you the ions. Now let's look at with a name, all right? In part 2, where it gets a little harder. What if I just give you the name? How do you get from a name to a correctly written formula? Because this is how you're going to see it in AP, exclusively. All right? Sodium iodide. Well, sodium is a group 1 metal. Iodide, I find it's group 7 nonmetal. So sodium iodide is the correct formula. All right, so use your periodic table, find which group it is. Now that you know that the group will give you the charge, then put it together. Let's look at strontium nitride. Okay, that's the very last one. Okay, we'll do one of those tough ones. All right, strontium is group 2, metal, so I know it's +2. Nitride is a group 3 nonmetal, so it's got a -3. So this is one of those great ones that the formula goes like this. So what I do is I take the name and I find the element on periodic table to figure out what charge it has. And once I know what charge it has, I know how to get it together because it has to be neutral when it's put together. All right? And we can do, I put potassium sulfide. No, I didn't put that one for this reason. But potassium sulfide, remember potassium has a symbol of K. It is a group 1 metal. All right? Sulfide is a group 6 nonmetal. So I need 2 potassiums for every 1 sulfide. All right? And that is how you name and write the formula of a simple main group metal with a main group nonmetal.